Hello friends, if you are pursuing BSc in any college under Dibrugarh University, then this video is for you. And I'm going to solve mathematical physics paper 1 set in 2019 of mathematical physics. So I'm not gonna solve the whole paper in a single video. I will take 2 or 3 more videos. I will make 2 or 3 more videos to complete this paper, because in one video it will be very long. Okay, so now let's start. What is the first question here? You can see, choose the correct answer. Divergence of curl of a vector. So divergence of curl of a vector is always 0. Remember that this is the correct option, right? So now next one is here you can see the paper here. The condition for the differential equation of this form to be exact, that correct option is this one, so option 2. So now next question, the order of differential equation is always positive integer, remember that. So that is your correct answer. So now let's move on to next question. So here you see, this is the question number 2, and here check whether the function defined by f of x is equal to x square minus sin x plus 5 is continuous at x is equal to pi, right? So now what we're gonna do here, first let me give you a note. The condition to be continuous, a function f of x is said to be continuous at a given point x is equal to a, suppose, where a is a real number. If it is possible, it will be continuous at a, x equal to a, if left hand limit at a and right hand limit at the same point will be equal to f of a. That means, how to find the left hand limit? So limit of f of x when x tends to a negative, that represents left hand limit, and right hand limit is given by limit of f of x, that when x tends to a positive. And here you see, in left hand limit put x is equal to a minus a, but and here put x is equal to a plus a. That means, now you see, this is the number line here, this is x is equal to a, so this is the left hand side and this is the right hand side, right? So if you take a point on left hand side, you can take this one as a minus a, right? So that's why for left hand limit we can put x is equal to a minus a, where a is a positive number, suppose very small positive number, and this point a minus a is very close to, very close to a. So similarly on this side you can put a plus h, which is very close to x is equal to a. So hope you have understood this. Why should I put this a plus h, a minus h, right? So now here you see, let me write the given function. Just wait. So first let me write the given function. Okay, so at x is equal to pi, so this function f of pi will be equal to pi square minus sine pi plus 5, and pi square sine pi is 0, so that's why you will get pi square plus 5, right? Now find the left hand limit. So x tends to pi negative, that means left hand limit of f of x. So limit, here you see, h tends to 0. So just wait, this, let me clean this. So here you see, f of x is here we are going to put pi minus h. Instead of x we are going to put pi minus h here, because you see here we have written h tends to 0. So why h tends to 0? When h tends to 0, x tends to pi. So here we have x tends to pi negative, right? So that means something on the left side of pi, right, which is very close to pi. So now we have changed this by h tends to 0. That is why when in such a way that when h tends to 0, pi tends to x tends to pi, right? So hope you have understood this. So then it can be written as limit when h tends to 0, f of, instead of x we are going to write pi minus h. So if you use this value here, here, then what you will get, limit h tends to 0, so pi minus h whole square. So we are putting the value of x here, sine pi plus minus h plus 5. So limit h tends to 0 and pi minus h whole square, and sine pi minus h, that's going to be sine h, right, plus 5 is equal to, if you put h is equal to 0 here, then you will get pi plus 5 again, right? So if you put h is equal to 0 here, then sine 0 is 0, so you will get this. So hope you have understood this. So now you see, let's find the right hand limit. So here we are going to put h tends to 0 when we will put x is equal to a plus h, sorry, pi plus h instead of a. We have pi here, so pi plus h. Just let me do one thing, let me clean this lines, right? So now use this pi plus h here again, so then you will get this result. Now if you put h is equal to 0, then you will get, just before that, let me write this one. So here you see, sine pi plus h is minus sine h, right? And this minus, it's become plus. So hope you have understood this, right? So now you see, pi square plus this one will be 0, sine h, when you put h is equal to 0, sine 0 is 0, so plus 5. So here you see, if you compare these three terms, these three results, pi, f of pi, then left hand limit is also pi square plus 5, f of pi is also pi square plus 5, and right hand limit is also equal to pi square plus 5. So all three are equal, and this condition is satisfied. Here you see, this condition is satisfied. So here you see, this part is not a part of the solution, just I have given the note. If you don't know how to find that, then using this note you can solve this problem. That's what I have done here. Okay, so now let's move on to next problem. Now question number 3, here we need to solve any two differential equations. There are two more equations I have not written in this slide. Next slide they are written. So here we are asked to solve any two. I will show all the three. Okay, let me show you how to solve this kind of differential equation. So here you see, this is of this form of this differential equation is this form. So in this case, generally differential equation, a solution of this equation consists two parts. One is pi, another is cf. So I would like to request you to watch all the videos made on differential equation. If you go to playlist and if you watch all the videos, then you will understand how to solve different form of differential equations, right? So what is pi, what is cf, how to find them. Okay, so it will be better if you watch those videos. I will provide the link of the playlist in the description box. Please go through them. Okay, now you see, this y is equal to pi plus cf, but in this form of equation where this is 0, so here pi is also 0, right? In this form of equation, here pi is also 0. So cf will be obtained from the auxiliary equation. Here you see, here in this case auxiliary equation will be m square plus pm plus q. So actually this part, you see, this left hand side part, this equation can be written in this form as well, right? D square, which represents second order differential coefficient, plus p into d. D means first order differential coefficient, q, and y can be taken out as a common like this. And if you replace this is your f of d, right? And if you replace m, and if you take f of m is equal to 0, that means this one is equal to 0. That is your auxiliary equation, right? That is how we have obtained auxiliary equation. So hope you have understood this. So now here you see, so we have different conditions depending on the type of solutions we will obtain after solving this. Okay, so that's why I would like to request you to watch all the videos made on differential equation. I will provide the link of the playlist. Okay, so now you see, this is our given differential equation. This is right here. Instead of p we have -3, and instead of q we have 2, if you compare with this form. So that's why here you see, so our auxiliary equation, if you compare with this, auxiliary equation will be m square minus 3m plus 2 is equal to 0. So if you solve this is a quadratic equation, right? You know how to solve quadratic equation, you have already learned in school level. So let me solve this. So I have used here factorization method. You can use the formula, quadratic formula as well. So here either m minus 2 is equal to 0 or m is equal to 1. So you can take any one of them as m1. So here we have got m is equal to 1. So we have taken this 2 is m1, and the next one is m2. Okay, we have taken this one as m1 and this one as m2, right? Two roots we have got, na? So here you see clearly these roots are distinct. That means they are not equal and they are real numbers, right? Real and unequal. So that's why if the roots are real and unequal, if you read the note here, if the roots are real and unequal, then CF is given by C1 e to the power m1x plus C2 m2x. If you put the value of m1 and m2 here, then you will get the CF. So our CF will be the solution. So here you see in this equation pi is 0. Since pi is 0 in such type of equations, so our solution will be only y is equal to CF. Actually this solution consists two parts, CF plus pi, but here we have pi is equal to 0 in this form. Okay, so the solution will be y is equal to pi plus CF. Pi is 0, so if you put the value of m here, m1 and m2 here, then your answer will be this. Now you see, you can it is not necessary that this one should be taken as m1, that m1 is equal to 2. You can consider this value also as m1. You can consider m1 is equal to 1, rather taking m1 is equal to 2, and you can take m2 is equal to 2 also, right? This way, then this value will be here and this value will be here. Our next equation is this. Let me solve it. So let me write the given equation. Here you can see what we can do here. Just transfer this on the other side, right? So now putting y is equal to b of x, b is equal to b into x, so that dy by dx, if you use the product rule here, then you will get b, derivative of x is 1, so you will get b only, then plus x, derivative of b, that is dv by dx, right? So that's what we have got. Let us use this in the above equation. So then you will get this. The above equation becomes this, right? So here you see, just put this value of dy by dx here and put y is equal to bx here. So then this x cancel, right? Then in the next part you will get this, right? So here again b cancels, right? b cancels. Then this is our remaining part, right? So again x will be also cancelled. Then dv by dx is 2 dx. Now let us integrate. If you integrate, you will get this result. So b will be equal to this is, then as you see, b, as we have taken here y is equal to bx, we have taken y is equal to b into x, so b will be our y by x. So let us replace this v by y by x. That is what we have done here. So then this is your solution. Y is equal to vx we are using here, since y is equal to v of x. So if you multiply both sides by x, then you will get this result. So this is your solution. So this is our next question. This equation is of this form, right? So on the right hand side, this time we have x to the power n. Here we have x to the power 1 actually, of this form. In this form, you see, this equation can be written in this form also, right? So x to the power n. So when this is 0, then pi is equal to 0, right? But now this is not equal to 0, this is not equal to 0. We have x to the power n, right? So then what we need to do? Now you see, this is your f of d, which is equal to d square plus pd equal to q, plus q, not equal to q. Then auxiliary equation will be your, if you replace the d by m and if you make that side is equal to 0, right, that will be your auxiliary equation. Now we are going to solve this to get the CF, right? And on the right hand side, if you have x to the power n, how to find a pi? Pi will be given by 1 by f of d into x to the power n. That's how we will get pi. Okay, this is the way to get pi. So let me solve it. Now you see, this is our given equation. This is our given equation. So in here, f of d will be d square minus 4d plus 3, right? So this is our auxiliary equation, right? This is our auxiliary equation. Just replace the d by m and make it equal to 0. That is your auxiliary equation. So when you write f of d, this y should not be written actually. So let me clean this. Here also y should not be written, sorry, not here. Okay, this is fine. So when you write only f of d, this y should not be written here. So now you see, let us solve this equation. This is quadratic equation. Simply you can solve by using factorization method. So here d square means second order differential coefficient and d means first order differential coefficient. So hope you know these things, right? So now you see, so let us solve this equation. So here m minus 3 is taken common. We have got m minus 1 into m minus 3 is equal to 0. So m minus 1 equal to 0 or m minus 3 is equal to 0. So from here we will get m is equal to 1, m is equal to 3. So let us take this one as m1 and this one as m2, right? So our CF is given by c1 e to the power x, actually m1x, right? m1x, this one m1x, as we are getting m1 is 1, so that's why we have got e to the power x only. So similarly c2 e to the power m2x, so m2 is 3, so that's why we will get e to the power thrice x only. So here you see, on the right hand side, this is x, that can be considered as x to the power 1. So if this is your right hand side, then you see, using this relation we can find the pi. Let us use this to get the pi. So pi will be equal to 1 by f of d. So our f of d is this one here. You can see this is our f of d, right? X to the power n means x here. So pi will be equal to f of d means d square minus 4d plus 3, right? And this is x to the power n. So here you can see d square minus 4d plus 3. Instead of writing 1 by f of d, you can write f of d inverse, right? That's what I'm going to do here. So we have I have written here d square minus 4d plus 3 whole to the power minus 1 into x. Now you see, we are going to express this in this form, 1 minus x or plus x, whatever you write, whole to the power minus 1. Then we're going to expand this using binomial theorem. Okay, so let me show you how to do that. Now you see 3 is taken common, so that we get d square minus 4d by 3 plus 3, sorry 1, not 3. So on taking 3 common, we have got here 1. So now you see, compare this one with x plus 1, or you can write 1 plus x to the power minus 1. Here you have minus 1, right, into x. So then what you will get? Now you see, so this is of this form 1 plus x whole to the power minus 1. If you expand it, you should get 1 minus x, then more terms you will get, but we are going to take only first two terms. If x to the power on x is 1, we are going to take first two terms. If you take you see, if you have power 2, then you should take first three terms of this expansion. If you expand, whatever you will get. The remaining terms are neglected here. Why? Let me tell you. So here this x represents our this term containing d. Now in the second term we will get d square minus 4d by 3, and it will operate on x. Now when you differentiate x once, then you will get 1, and if you differentiate it again, then you will get 0. Okay, so in the second term we have d square and d also, so we will get a value for d, but for d square we will get 0. So in the next term we will get d to the power 4 and d square, d to the power 4 and d square. In both cases, derivative of x, if you differentiate x 4 times and 2 times, then you will get 0. That's why remaining terms are neglected. So hope you have understood this. So to understand better, just watch all the videos that I have made on differential equation, right? So now what we can do here, so now 1 by 3, that 3 to the power minus 1 will be 1 by 3, then it can be written as 1 minus d square by 4d by 3, right? So that is what we have got after expansion using binomial expansion into x. Now 1 by 3, x into 1, that's gonna be x into 1, x into 1, we have got x here, then x into this, if you operate on x by this d square minus 4d by 3, then what you will get? Second order derivative of x is 0, right? This is 0, and if you differentiate x once, then you will get 1 here. 4 ones are 4, right? So ultimately our result will be, sorry, 0 minus 4 by 3. That implies x by 3 minus plus 4 by 9, right? If you take 9 LCM, then you will get thrice x plus 4 by 9, right? So here you see, let me clean this. So what will be our solution? Therefore the solution, y is equal to, we know CF plus PI, right? So what is our PI? What is our CF? CF is this one. We have got this CF. So this is our CF, right? You can see. So this is our CF. So we have used here, and PI we have got this. This is our PI, right? Let us use here. So then we got the solution, right? So this is our solution. That's how we can solve such kind of differential equation. So this is our next question. State the existence theorem and uniqueness theorem to check whether a solution of a differential equation for a particular boundary value exists or not. Okay, so first, existence theorem will give the we will check the existence of the solution using the existence theorem, then it is unique or not. That's going to be given by the uniqueness theorem, right? Suppose we have an initial value problem. Suppose let us consider an initial value problem, dy by dx, which is equal to f of x and y, and with the initial value y of when y value of y when the value of x is x naught, then y is equal to y naught, right? So here you see, then the solution of this initial value problem will exist if f of this function f is continuous near the point x0 comma y0. That means, suppose, let me take, this is your xy plane, this is your xy plane, so this is your point, suppose x0 y0, okay, and we have taken a region, okay, which is very small region around this point. Then near this point, if the function, this function of x and y is continuous, then we can say that solution of this initial value problem does exist, right? So now, is that unique or not? So now you see, uniqueness theorem says that if the differential partial derivative of f with respect to y is continuous near this point, then solution is this solution is unique, okay. So here this function f is this function of x and y. So these are the theorems, existence theorem and uniqueness theorem. So our next question is this. So here we are going to find a partial derivative of this function f of x and y. This is a function of both x and y. So we are going to find a partial derivative with respect to x, also with respect to y. Then we are going to find a second order partial derivative with respect to x and y, right? So first let us write a given function in the solution. So let me write the given function. This is f of x and y, that is log of x square plus y square. So partial derivative of this function f of x, so let us consider this part as this one as log of x. If you assume that way, if you assume that this is log of x, then what you will get, and derivative of log of x with respect to x, that's going to be 1 by x, right? So you know that. So then you will get, we know, derivative of, just wait, so now you see, that's what we have got here, 1 by x square plus y square. So if you assume this one as x, then again, but it is not x, it is function of function, you can say this is function of function f of g of x, like this, right? So that's why what you have to do here, again you have to differentiate this term, right? Again you have to differentiate this with respect to x square plus y square. And if you differentiate this, so this y should be considered as y, because here it is partial derivative, right? Then we are doing the partial differentiation with respect to x, that's why we will take the variable as x, and we are going to consider this variable y as constant, right? So then what you will get, if you differentiate x square, then you're gonna have twice x, right? So twice x by x square plus y square. So this is our del f by del x, partial derivative of f with respect to x. If you find the, let us find the partial derivative of second order partial derivative of f with respect to x. So we have differentiated already once. Here you see we have got this result. So let us differentiate it again, then you will get the second order derivative, right? So hope you have understood this. So second order partial derivative of f with respect to x can be obtained by differentiating this using this rule, u by v, derivative of u by v, v derivative of u minus u derivative of v by v square. That's how we can do. So this is the denominator v, you can consider x square plus y square, and derivative of twice x, partial derivative of twice x with respect to x, then minus twice x, that is u, then derivative of v, that is x square plus y square, right, divided by v square, that is x square plus y square whole square. Now differentiate twice x and x square plus y square. If you differentiate twice x, you will get 2 only, and if you differentiate x square plus y square with respect to x, then you will get twice x. So this is twice x. So here you will get twice x square plus 2y square as we have got here 2, so this 2 is multiplied here and here also. So then minus, here we have got twice x, it's gonna be 4x square, right? 4x square divided by v square, that is x square plus y square whole square, right? That's gonna be equal to twice x square minus 4x square, that's gonna be twice y square minus 2x square by x square plus y square. So this is your answer, right? So now let us differentiate this function f of y. Let us differentiate this with respect to y partially. So we're gonna apply the same rule. Yeah, 1 by x square plus y square. Again, if you differentiate with respect to y, if you differentiate again this part which is within bracket, then here if you differentiate this part, you will get twice y. You have to consider here x as constant because we are differentiating partially with respect to y, right? So then you will get twice y by x square plus y square. So here you see, if you differentiate this again, then you will get the second order derivative of f with respect to y, partial derivative, right? So again you have to use the u by v rule. U by v, its derivative is given by v, derivative of u minus u, derivative of v by v square. If you apply this rule, then x square plus y square, that can be considered as v, and derivative of twice y with respect to y minus twice y, derivative of x square plus y square with respect to y, right? So divided by v square, that means x square plus y square whole square, right? So here you see derivative of twice y is simply 2, and derivative of x square plus y square, it's going to be twice y now, because x is constant here. We are going to assume as constant because it's partial derivative, right? So hope you got it. So doing so, we have got this result, and finally we will get this, right? So that's how we can solve this problem. So hope you have your next question. This is question number 4, B1. So let us solve this. So this is a partial differential equation. So first, let me write the left hand side in this way. It can be written this way: del by del x of del z by del x cos of twice x plus thrice y. So how to integrate it with respect to x? So if you integrate this, with respect to x, then what you will get? Then this part will be removed. Then you will get del z by del x. So let me use another ink here. Del z by del x, and integration of cos of x, we know sin x. So sin, instead of x we have twice x plus thrice y. Then divided by the coefficient of x here. This, right? We know that. But here you see, if you are getting this, due integration of this one with respect to x, you are getting this one, sine of twice x plus thrice y plus divided by 2. So if you differentiate this, then you should get this term again, right? Okay, obviously you will get this. And one more thing, suppose, what if you have a function of y, suppose any function, suppose you have 5y, 4y, 45y, whatever you have. If you differentiate this thing, then also you will get this, because if you differentiate this with respect to x partially, then derivative of this function of y will be 0. That's why you see. So what should I write here? We should write a arbitrary constant, arbitrary function, that is, suppose f of, let me write f of y, f1 of y, right? f1 of y. So if you differentiate this, then it's gonna be 0. If you differentiate this one with respect to x partially, then it's gonna be 0, right? So now you see, let me write where f1 of y is an arbitrary function. Arbitrary function. of y. So similarly, if you differentiate it again in order to get the value of z, or sorry, integrating with respect to x. If you integrate this again, then you will get the value of z is equal to, and integration of this one, integration of sin x is minus cos x, cos of twice x plus thrice y. There is already a 2, then again you have to multiply here coefficient of x, so that's why that's gonna be 4. So here its denominator gonna be 4, and what should be derivative of what? You will get f1 of y. If you differentiate x into f1 y with respect to x partially, then you will get this. So that's why integration of, you can write that integration of f1 of y is equal to this. You can write that way. So, and again that suppose if there is a 0, suppose, so you can consider that f2 of y, here you can write f2 of y. Okay, if you differentiate this with respect to x partially, then you will get 0. So this is your answer. So that's how we can solve. So this is your solution of the differential equation, partial differential equation. So hope you have understood. So in this video we have solved from question number 1 to question number 4b1. So from the next video we are going to solve from question number 4b2, right? And I will complete this paper in 2 or 3 more videos, because if you solve all the whole paper in one video, that's going to be very long, and so that's why I have decided to solve it in 2 or 3 more videos. So in the next part you will get solutions from question number 4b2, right? So hope you will like this video. If you have, then hit the thumbs up button, and if you're new to my channel, please subscribe the channel. Also hit the bell icon so that you get notified when new video will be uploaded, and share with your friends. So thank you for watching. See you in the next video.